Hello friends, this video statistics part 6 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 5. Comes the measure of dispersion. Measure of dispersion will help you now. What is measure of dispersion? It is the measure of variability or spread or scatterance of data. It will tell you how scattered data is, how variable data is, what is the maximum value, what is the minimum value. So if you see, the center tendency was telling you what is the center point of data, right? Mean, median, mode was, all these were telling you what is the center point of data, which guy has the maximum frequency, or what is the mean, what is the mode, what is the median. So these things were telling you the center tendency. But now in case of dispersion, it will tell you the measure of variability of the data, how spread data is. Now if you see, the central tendency and the dispersion both are contrasting, but they together will give you the exact picture of data. Neither central tendency nor dispersion alone can give you the best figure. You need both. Both of these will give you the exact figure. So for the data, what we'll do, we'll find central tendency, we'll tell, okay, this is a central tendency. Also we'll find the scatterness. So if we have the scatterness and if we have the central tendency, if we have both of central tendency and scatterness, using these two, we can give the exact data. What we can interpret the data in a better way. Using central tendency and using measure of dispersion, we can interpret data in a better. We have types of dispersions. We have range, quartile deviation, mean deviation, and standard deviation. We'll explain this. Just to repeat, measure of dispersion is nothing but it is the measure of variability or spread or scatterness of data. It is contrasted, is exactly contrast. It contrasts with the central tendency, but central tendency and measure of dispersion, you combine both these two, it gives a better idea about the data. We can interpret data in a better way using both measure of dispersion and central tendency together. What is range? Range is nothing but maximum value minus minimum value. So for the same data, if you see, we have the same guy, player 1 and player 2. This guy is player 1, player 2. Now if you see, the range for player A will come out to be 52 is the maximum value, 48 is the minimum value, 52 minus 48, that is 4. Similarly, the range for player B will come out to be 100 minus 0, that is 100. So only with this data we can't tell anything. So if I am told that range of player A is 4 and range of player B is 50, I can't tell much. But the only thing I can tell is that this guy is consistent and this guy is not consistent. But I can't tell whether it is good or bad. So if you have this data also, that the maximum mean is 50, median is 50, mode is 50, and range here is 4, and here range is equal to 4. So if you add this data also, with this data I can get a clearer picture. So if I am told that, if I am not having this data, this is hidden from me, and if I am told that mean, median, mode are 50 and range is 100 for this player A, and for player B, and for player A the range is 4, mean, median, mode is 50, I can tell that player A is better because here this guy is more consistent and the runs are same. Correct? So only with this measure of dispersion, that is only with range, it doesn't give the clear picture, but range with mean, median, mode, it gives a clearer picture. Correct? Now we'll take quartile deviation. It is based on the lower quartile and the upper quartile. The difference is called the inner quartile, and the difference divided is called by 2, divided by 2 is called semi-quartile. So here you see the formula is quartile deviation is Q3 minus Q1 by 2. Q3 is this value, n plus 1 by 4 term, and Q3 is 3 into n plus 1 by 4 term. So for the same data I'll find quartile deviation and I'll see both are different. So here Q1 will be n is equal to 7 here, 7 here, 7 here, 7 plus 1 by 4th term, right? That is second term. And the second term here we have is 49. I'm calculating for player A first. 49. Similarly, Q2 will be 3 into 7 plus 1 by 4 term is equal to 6 term. And the 6th term is 51. So this becomes 51. Correct? Now for player B, Qn again will be same, 7 plus 1 by 2th term to the second term, and second term here is 25, and Q3 is Q3 will be again 3 into 7 plus 1 by 4th term. This will be 6th term, and the 6th term here is 99. So for player A, QD is equal to 51 minus 49, that is Q3 minus Q1 by 2. Correct? And that value is 2 by 2, that is 1. For player B, QD is nothing but 99 minus 25 by 2, that is 74 by 2, that is 37 by 37. So we can see that the values are different. So here we can say that QD is equal to 1, and here we can say QD is equal to 37. So with this data also I can see that this is more dispersed and this is less dispersed. That means this guy, the first guy, is more consistent, player is more consistent, and player B is not consistent. So QD's quartile deviation is also similar to range, but the advantage here, it ignores the extreme values. For example, these values are ignored here, if you see, right? So the extreme few values are ignored in the quartile division. It is better than range in some case. Correct? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.